Hello everyone, today we are going to discuss about the full adder and what is the limitation of the half adder that we already discussed in the last class, and what is the limitation of the half adder. The limitation of the half adder is which can capable of adding the two binary bits only. Okay, but if you want to add the three binary bits, then you go for the full adder, and this is the block diagramic representation of the full adder. It have the three inputs which are labeled as A, B, C in or in short form. I am also writing it as the C. You can write it as the C in or C. Okay, the inputs are A, B, C or A, B, C in, and whatever the outputs of the full adder, it have the two outputs, and which are sum and carry, and carry is nothing but the carry out. Okay, in short form I am writing the sum is equal to S and carry is equal to C out. And here this is the truth table of the full adder. Okay, as per the block diagramic representation of the full adder, it have the three inputs. Here I written the three inputs, and it have the two outputs, and here I written the two outputs. And with three inputs, the possible combinations are 8 combinations, and you know, if n is equal to 3 and the number of possible combinations are 2 power n 2 power 3 equal to 8. Here I written the all the 8 possible combinations in the sequential order. The first combination is, the first possible input combination is 3 zeros. Next one is 0 0 1 0 1 0 0 1 1, nothing but the 3 4 5 6 7. So total different input combinations are the 8 input combinations. Okay, for each input combination you just write the what should be the expected value of the sum and carry output of the full adder. Okay, to the full adder, if the three inputs are 0 0 0, and what about the sum output? Sum is equal to 0 and C out are nothing but the carry output equal to 0. Next case, when A0, B0 and C in is equal to 1, okay, you add these three, and then what is the sum output? 1. And is there any carry generated? Not generated. That's why you just write it as the C out equal to 0. Okay, in that way you just try to fill the table. Anyhow, I will explain the last case. So here all the three inputs are 1. 3 inputs are 1 1 1 1 1 1 1 plus 1 2 2 plus 1 3, and 3 in the decimal form. Its binary equivalent value is the 1 and 1. In that, sum is equal to 1 and carry out is equal to 1. In that fashion you just try to fill the truth table of the full adder, and based on the truth table you should be able to write the Boolean expression for the outputs of the full adder. The first output is the sum, next output is the carry out. We already discussed how to write the Boolean expression for the output variables. So first consider the sum, go to the corresponding column. In the sum output column, wherever the ones are present, go to the corresponding input combination and try to express the corresponding input combination in the algebraic form. Okay, so here 1 is there. Okay, you just try to express it in the algebraic form. In the algebraic form of this input combination is A bar, B bar, C in. Okay, next one is the, so here I am writing sum is equal to sum, or S is equal to A bar, B bar, C in, plus, and the next one is the this one. Go to the corresponding input combination which are 0 1 0 0 represent in the algebraic form with complement A bar, B, C in bar. Next one is the A bar, B, C in bar, and come to the next one. So here 1 is present, and go to the corresponding input combination which are 1 0 0 and try to express it in the algebraic form. Okay, wherever 1 is present, represent it in the uncomplement form. 0 represent within the complement form, then it becomes the A, B bar, C in bar. Next term is the A, B bar, C in bar. Okay, and the next one is the, so here go to the corresponding input combination. All the input combination values are 1 1 1. So therefore the corresponding algebraic term is the A, B, C in. Okay, A, B, C in. You just write it in the short form as in the min term form as, the first one is the M1, next one is the M2, next one is the M4, and next one is the M7. And this can be also be written as sigma M of 1 comma 2 comma 4 comma 7. The same thing I written here. Okay, in that way you just try to fill the you just try to write the Boolean expression for the C out in the short-handed form, which is equal to C out equal to sigma M of 3 5 6 7. Okay, 3 5 6 7. Once you return the Boolean expression for the output variables. Okay, as per the design procedure of the combination circuit, you just try to simplify those two Boolean expression to the possible extent. For that purpose, you just take the help of the K-maps. Okay, so here which K-map is suitable? 3 variable K-map is suitable. Why? Because in our design, okay, in our full adder, we have the 3 inputs. That's why you just take the 3 variable K-map. Okay, here I drawn the 3 variable K-map. One is for the simplification of the sum expression. Next one is the simplification of the carry expression. Okay, so in this 3 variable K-map, okay, you just enter the corresponding min terms. You map the corresponding min terms into the K-map. So once I mapped, therefore the resultant min terms are like this. Okay, so here just by observing this 3 variable K-map, there is no adjacent min terms are there. All the min terms are isolated and the grouping is not possible. So therefore we can write this simplified expression as A XOR B XOR C. So this is the simplified Boolean expression for the sum output. Next come to the Cout. In the Cout also, and to write the simplified Boolean expression for the Cout, you map all the min terms into the K-map. So here the min terms are 3, 5, 6, 7. So 3, there you write 1, and 5, this is the 5 position, 6 position, 7th position, and group the adjacent min terms. Okay, so as per this K-map, these two are the adjacent to each other, and these two min terms are also adjacent to each other, and these two min terms are also adjacent to each other. Okay, you first consider this two group. Okay, from this two group, the simplified term is so here the row is common A, and these two group min terms are belongs to the columns of B bar C. Next one is the BC. In these two columns, which literal is common? C is common, and B bar and B both are cancelled to each other. You just take it as the common literal AC, that is the C. Therefore, the min term, simplified min term is the A into C plus. Next, consider the second group. This second group, and from this the simplified min term is the A into, in these two columns, which is the common literal? B is the common literal. You just write that common literal AB plus. Next, consider this two group. Okay, so here these two group go to the corresponding columns, corresponding rows. The min terms, the literals are A and A bar, both are cancelled to each other, and go to the corresponding column. Here the min term is the BC, and write that simplified and write that term. Therefore, the simplified Boolean expression is the Cout is equal to AC plus AB plus BC. I am writing it in order AB plus BC plus CA. So therefore, these are the simplified Boolean expression for the full adder. Sum is equal to nothing but S equal to A XOR B XOR C, and Cout equal to AB plus BC plus CA. You just realize these Boolean functions using the logic gates. Okay, so here, and to realize this Boolean function, here I consider the 2 XOR gates with 2 XOR gates. Each XOR gate have the 2 inputs. Okay, for the first XOR gate, this is the XOR gate 1, XOR gate 2, AND gate 1, AND gate 2, AND gate 3. So here for first XOR gate, the inputs are AB, output is equal to A XOR B. Okay, for the second XOR gate, the inputs are, one is the A XOR B, next input is the C nor C, and this is C, and what is the output of the second XOR gate? A XOR B XOR C. Okay, so this is equal to the sum expression, and same way you just try to realize the Boolean, this Boolean expression Cout using the logic gates. So here, based on that, I consider the here 3 min terms are there, 3 product terms are there. That's why I taken the 3 AND gates. For the first AND gate, the inputs are AB, second AND gate, the inputs are BC, and third AND gate, the inputs are CA, and all the outputs of the 3 AND gates are connected to are given to the input of the OR gate, and therefore OR gate output is the AB plus BC plus CA. So this is the way to realize the logic diagram for the 2 Boolean expressions of the sum and carry. Okay, so this is about the complete design procedure regarding to the full adder. Thank you.